Hello everybody, in this video we are going to learn about the effects of groundwater pumping. Alright, the very first effect of groundwater pumping is the cone of depression. So what is a cone of depression? It's just a change of water, the shape of the water table. Initially the water table in this illustration is flat, horizontal, that looks something like this. Once the pumping started to happen, the shape of the water table around the well will start to change. Okay, and it will start to change to be a conical shape of depression again around the well during pumping. Now, why do we have to care about this? Well, first of all, say in this illustration we have a large well here on the right side and we have a small well here to supply the water maybe for this house right here, and the large well is actually supplying water for the agricultural industry right there. Okay. And this is what the water table looks like before pumping. Now let's take a look at how the water table looks like after pumping. So this is what it looks like. So the cone of depression will start to form, and then what we need to pay attention to here is that the cone of depression here on the right underneath the large well, will be so big it actually lowers all the way the water table here on the left side to be all the way below the level of the well, the level of the smaller well. Therefore, as a result, the house will not be able to pump any more groundwater to the surface. Again, because of the effect of cone depression on the right side here. Okay, and the formation of cone depressions will eventually lead to the second effect, which is called the lowered water table. So once this happens, it really just the water table drops below the usable depth through excessive pumping. As you can see here, the big wells might still be able to like produce fresh water to the surface, but there's no hope anymore for this well because it becomes dry, because again the water table drops below the usable depth. And then the third effect that I would like to mention in this video is called saltwater intrusion. So what is saltwater intrusion? It is a process of pulling salt water into freshwater aquifers. So for example, here we have fresh groundwater right here in blue, and here we have salty groundwater in kind of like greenish color right here. Typically saltwater intrusion happens in regions or in areas very close to the ocean. Okay, typically in New Jersey we have the same issue here. We have this issue in some cities such as in Cape May or Atlantic City in southern New Jersey. These are some examples of cities that have this issue in New Jersey. Okay, so what happened here is that we have a piece of land here that has not been developed yet, and then of course when people start to move in and then they require water, they pump the water out of the ground. Now when the pumping process happens so excessively, what happened here is that these well can start, instead of producing the fresh water from this blue layer right here, they will have salt water comes into the well. Okay, right here. Now once the salt water comes into the well, it will start producing, and it will keep producing salt water throughout the age of that well. Here's a real study of saltwater intrusions affecting Cape May in New Jersey, and here we have the data from 1940s right here. They thought that they had saltwater intrusion starting in 1940s, but at that time it had not affected the wells that are located in Cape May yet. But eventually, in 1950s all the way to 1990s, in 1990s we can see that this saltwater intrusion comes here from the left, and now by 1990s it already had affected 1, 2, 3, and 4 wells in Cape May. 4 out of 5 wells at least for this study. So again, of course, once these wells pumping salt water out of the ground, and they will just keep pumping salt water to the surface. Therefore, there's no other way to, except to abandon these wells and create new wells, maybe. Okay. All right. The next effect of groundwater pumping is land subsidence. Okay, so over pumping can cause grains to settle. So what does it mean by this? Remember that groundwater is mostly stored in pore spaces, like the spaces in between the rocks, in between the grains of the rocks. Okay, so this water occupies some space. Okay, but once you take the groundwater out of these pore spaces, what happened here is that the grains will start to settle, because again, of course, once you take out the groundwater out of these pore spaces, everything will just start to collapse. Okay, because there won't be any water pressure left to hold these grains together. So the grains will collapse and eventually create the land subsidence on the surface as well. Land subsidence is a real thing, and it can be very devastating in some regions. For example, here in Joaquin Valley in California, they had a very, very, massive land subsidence, I would say. This is the land level in 1925, and then the land has been dropping all the way since 1925 to the level right here in 1977. And as you can see here, here is a person as a comparison to the amount of land subsidence that happened in Joaquin Valley in California. Okay. The very last effect for this would be sinkholes. Sinkholes are literally just big holes that form on the ground surface, and typically this happens because of the presence of limestone bedrock or carbonate bedrocks, and these bedrocks are known to be something that can get easily dissolved in water. Okay. So as you can see here, I give you example of caves that form in carbonate or limestone material. And again, the formation of caverns right here, they are mostly caused by dissolution of limestone or carbonate rocks. Sinkholes, sometimes it can have amusing consequences, like this one right here, but they can get fairly serious. And something like this. This is literally a house, falling down into a sinkhole right there. And some sinkholes can be very devastating and dangerous. And I think that'll be all for this topic. And I'll see you again in the next videos in other topics. Bye bye now.